Okay, so we have a second example here with a hyperbola. It says write the standard equation for the hyperbola whose vertices are at negative 7, 0, 7, 0, and whose co-vertices are at 0, negative 4, 0, 4. Then graph the hyperbola. Okay, so I'm going to shrink this a little bit, and then we're going to go ahead and walk through the problem. Just like we did the other one, I'm going to speed it up a little bit though. So hyperbola. So I know I have a choice of equations. I'm going to go ahead and write these kind of towards the top here. And my choices are, I could have x squared over a squared minus y squared over b squared equal to 1, or I could have y squared over a squared minus x squared over b squared is equal to 1. So I have to look and determine where the vertices are. And the vertices are at negative 7, 0, 7, 0. So the movement is on the x-axis. So the movement is telling me that because it's moving on the x-axis, that I'm going to deal with this guy right here in red. And so then that means that I'm dealing with a hyperbola that opens to the left and to the right. Okay? So then I think to myself, okay, well, what's the center? Well, I know the center is the midpoint of the vertices. So if I take my x's and add them together and divide by 2, and I take my y's and I add them together and divide by 2, I'm going to get 0, 0. So I know the center is at 0, 0. So I'm going to go ahead and plot that point real quick right there. And so because I know the center is at 0, 0, I've moved 7 units from the center to go to the vertex. So then that means A is equal to 7. These are a little easier because it's centered at the origin, so we should know just by looking at these guys right here that it's at the origin and A is equal to 7. So then by that same rationale, we see that the co-vertices, the movement is on the y-axis, so I know B is going to equal 4. And then in order to find C, or any of the other pieces for that matter, I'm going to use the formula ax squared plus b squared is equal to c squared. So what I'm doing is a couple things. Is I know this formula is slightly different than an ellipse. In a hyperbola, we subtract the equations, subtract the terms. So when I use this little formula that we have, which is Pythagorean theorem, I'm going to use a plus. Okay? So that means to find c squared, I'm going to go ahead and plug in my guys here. I got 49 plus 16 is equal to c squared. And so c squared is going to equal 65, so c is equal to the square root of 65. So I know c is root 65, and for graphing purposes, this is approximately 8.1. And then that way I know where to plot it on the graph. I need exact values, though, when I label everything. So let's put the equation together. I know it's centered at the origin, so there's no translation. So it's going to be x squared over a squared, which is 7, so that's going to be 49, minus y squared over 16 is equal to 1. So there is my equation. Now I'm going to start graphing everything. So a couple ways that we can do this to find vertices. I'm going to go ahead and in the top right, I'm going to list a is equal to 7, b is equal to 4, and c is equal to root 65, which is approximately 8.1. Let me go ahead and zoom in on the graph here real quick. And so in order to plot this, A, because it is a vertex, I'm going to move, and it's a x direction, I'm going to move 7 units from the center. So if I move 7 units from the center, right, I'm just going to count 7 units, and I'm going to end up right here. And so really what I'm doing is to find the vertex, or vertices, I'm taking my center and adding them and subtracting those 7 units. And so my vertices are going to be 7, 0, and negative 7, 0. So I add that to my x values. And so let me plot the other one right here. And so this is 7, 0, and this is negative 7, 0. And now I want to do the co-vertices. So co-vertices, I'm going to take, it's 4, so I'm going to take the center and I'm going to add and subtract 4 from the y's. So my vertices are going to be 0, 4, and 0, negative 4. So I'm going to go down 4 from the center, and I'm going to go up 4 from the center. And there are my co-vertices. And then for the focal points, I'm going to add that to my x's because they're always on the point where they open. So I'm going to add or subtract root 65. Nothing changes with the y's, so the focal points are going to be root 65, 0, and negative root 65, 0. And I'm going to go ahead, the other thing that we did in the previous video, now that I have all these guys, I'm going to wait to plot the focal points until I have the picture graphed. One of the things that we did is we had this dashed box that we put around, and I create a box or a rectangle that the vertices are the intersection of the vertical and horizontal lines that intersect through the vertices and co-vertices. And then what we did is we graphed these asymptotes, and I'm going to go ahead and put these in blue, that they will be connected through the center from opposite vertices. Okay, so when we graph hyperbolas, we have to talk about these asymptotes or graph them. And I have my asymptotes here, and now I can go ahead and get the width of my hyperbola. And I'm going to go ahead and draw these in. There's one, there's the other, and then I'm going to go ahead and plot the focal points. And that was about 8.1. So here's my focus, here's my other focus, and then up here was a co-vertice, and down here was a co-vertice. And there we go. That's graphing a hyperbola. That's our second example.